started. Welcome back. I know the school year hasn't started yet.
I know, welcome. I like this early anticipation of NetSeminar talking.
Okay. Well, welcome to NetSeminar. This is our first seminar of the year. Today we have Andrew Rice, who is a senior lecturer. Thank you. Who's a senior lecturer at the University of Cambridge in the computer laboratory. His current research is focusing on programming language design and theory and applying that to scientific computing. He previously focused on using smartphones as a computing platform and associated energy consumption, and he also works within the Computing for the Future of the Planet framework. So without further ado, here's Andy.
Great, thanks. Thank you all very much for coming. It's really great to be here. It's my first time in Stanford. So about 5 years ago, we were looking at mobile phone power consumption, and we did some measurements, came up with a simple change you make to the handset to save 4 joules when you connect to the Wi-Fi. This was back in like G1's Nexus 1 kind of times. And what we were then interested in is this a significant saving? Does it matter? And so we were looking for data sets to say whether or not people connected to the Wi-Fi enough times a day to make this a worthwhile saving. And we really failed to find anything that would really do the job with that. And so we kind of forked what we were doing and started Device Analyzer, and the idea was to try and build a data set that said what people were doing with their smartphones, and also to build it in such a way that we could then share it with other researchers and industry. I'm going to tell you a little bit about what we built and how it works, but I'm going to focus more on the kind of things that we and some others have done with the data, and hopefully by the end, everyone in the room who's got an Android phone will want to install the app and carry on contributing. So Device Analyzer itself was built by one of my PhD students, Daniel Wagner, and it's a free app that's on the Google Play Store. And we set it up with no direct rewards for participation. So the app is available for free, but we don't pay anyone to participate. We noticed from the reviews on the App Store that people are getting indirect rewards, in that people say things like, it's good to be contributing to research, and it's nice to know that this data is going into that. There are also, you can go and look through them, there are also lots of reviews on the App Store that accuse us of being the NSA and stealing everyone's data, so you get both sides. But lots of people have really sort of participated of their own free will with this. And some of them have contributed more than 2 years of data, so we've got some really sort of long-term views about what people do with their handsets and how that changes over time, which you often don't see with some of the shorter studies, which are necessarily limited to shorter periods. So these are my guys with their 2 years worth of data, and unfortunately this is a log scale graph, and so you can see that the vast majority of people who contribute to the data set are sort of below a month. They're actually around about a day or less. So although we can say there are 23,000 people who've contributed data, actually if you want to say, well, I need at least a couple of months worth, then it goes down fairly quickly and you're looking at thousands rather than tens of thousands. We think that maybe you could still get useful stuff out of the very short participation period, so it's in there, but you might need to filter the data a bit. So I just mentioned long-term variation, so let me give you an example. So this is RSSI from the cell network, so signal strength, and the graph on the right is one row of pixels for each user from the data set, sort of stratified sample going through the data. And green colors are good signal strength and red signals are bad, and so people near the bottom of the graph are not having a very good time of it. On this side is a sort of a longitudinal view, and I just want to show you this user at the bottom, who for the vast majority of their time has sort of poor signal strength, but they're getting by, and then there's a period of 4 weeks here where all of a sudden they've got nothing at all, and then they go back to normal again. And of course, we all know that we go on holiday, we go away, we go to a conference, and so our behavior changes for a period and then it goes back again. But really this is often overlooked when people are evaluating different algorithms that are using, say, predictive ones. So you build an assistant and you evaluate how good it is at predicting what people do. It's really good for the time when I'm doing the same thing, but the time when I do something different and when I need an assistant, that's the time that you should really be looking at. And so these long-term variations, I think, are important for people to look at when they're evaluating what they're doing. So I think it's great that we've got some users with this long-term view. How many people here are Android programmers or have ever flirted with it? Yeah, one. Okay. iOS, more iOS. Okay. So I'm sorry, Device Analyzer is Android only. The iOS APIs don't let you do this stuff. So we get a bunch of OS events, so connectivity changes, screen activations, things like that. The Android OS actually delivers events to us and we just swallow them up. Some things that you really might want to know about, there are no events for. So lots of people want to know which apps are running on the phone, and there are no events that tell you when an app starts or stops. So instead what we do is poll that information out of proc by talking to the Linux kernel. And things like network counters, again, you also have to poll those to know sort of how much data is going through. So Device Analyzer does a mix of these two things. When we poll data, it's every 5 minutes to try and reduce the energy consumption of the app. On our own handsets, it looks like Device Analyzer consumes about 3% of normal energy use. But if you look at the App Store, there are a good number of users who are accusing us of rather higher percentages than that. Who knows? We can't get bug reports, so we don't quite know what's going on. 10% of the time that you turn your screen on, Device Analyzer enters a high frequency mode and polls at half-second intervals rather than 5-minute intervals. And we were interested in whether that sort of statistical high rate sampling was useful or beneficial to anyone, but so far I don't know of anybody who's used that feature in the data set. The slides are going to be online later, so if you want to know more about exactly which things we collect, then it's exhaustively listed on the website. So I said that we wanted to share the data. So the first thing that happened is that when you install the app, you have to activate it and consent to the data collection. And roughly 50% of downloads are never activated. So half the time people download it and they either delete it immediately or they forget about it. I don't know what happens, but they don't turn into activations. Our original plan was that we wanted to share the data just verbatim without any sort of overheads. People could just download it. And so we hashed some of the data that we thought was sensitive actually on the handset itself before we even collected it. And this also means, obviously, if our servers get compromised and someone steals the data set, there's not sensitive information in there. But it means you can't use Device Analyzer to do social graph analysis. You can't link two devices together as part of it. We asked people to opt in if they wanted to share location information or the names of which applications they're running outside of Cambridge. And as you can guess from an opt-in process, the vast majority of people didn't tick the box. And so if you get the data, you'll find that most locations and app names are actually hashes of the true value. We have the data in the Cambridge data set, and we've had people come in and collaborate with us to process the data within Cambridge, and that's obviously fine. The thing that's probably been most well received is an option to retrospectively opt out. So we never process or release any data that isn't 3 months old. And that means that at any point you can hit the button and say, please remove at least 3 months of my information from the data set, and we can guarantee that nobody's got that. And people seem to like this feature. It means you can play around with it for a couple of weeks, talk to your mates, and then decide that you don't want to participate, and you can sort of opt out that way around. I'm not aware of other studies doing this, but technically it's obviously trivial to do. And so one of the things that we do in future is something like this again. So rather than a zero overhead approach for getting the data, we ended up with these 2 steps. So first of all, you have to email us and ask for sample data. And these are 8 phones, which we have explicit consent from the participants to share their data just with anyone. And about 250 people or companies have contacted us and requested a copy of this sample data. The idea with the sample data is that people work with it, check that it actually has the information in it that they need, and that they can do the algorithms that they want. And then once they've established that, they send a detailed proposal, a legal agreement sent by post, just to make sure that they've actually thought about the fact it's a legal agreement. And about 64 organizations have gone through that. So compared with our enormous cutoff of device activation, actually there are quite a good proportion of people going through to the second phase of this. The legal agreement simply says that you may not try and work out who any individual in the data set is, or release any tools that help other people to do that. So any commercial exploitation is fine, any research application is fine. It's just we just want to protect the people in the data set. We asked the university legal office to write the most permissive license that they could with that principle in it, and they said we've done it. And then every time we send it to someone, their lawyers get in touch with our lawyers, and then the agreement is then negotiated. And so with hindsight, I think when we said, please write the most permissive one you could, they didn't actually do that. And so we still have to negotiate on the licenses, but that just seems to be the way of it. The detailed proposal is there to make sure that people actually have a real application for the data. So one of the principles of data disclosure in the EU is that there must be for a specific purpose. And so we're just sort of doing a little checking to make sure that purpose exists. So the first question you might have is, how representative is this data? And the answer is we don't really know, because we don't collect any demographics about the age or the gender of the people who are participating in Device Analyzer. And so, but you can look at some of the things within the data set to try and get a feeling for this. And this is some work done by another PhD student, Daniel Thomas, who was looking at this information. So the graph on the top here shows you the API versions reported by devices in Device Analyzer. So this is like the version of the API that the Android device presents to the programmer. And this is the distribution of API versions which Google publishes about the distribution of devices using the Play Store. And they publish this information so that developers know which versions of Android they should target. So you can see up to about here, we were doing reasonably well, apart from there's a bit of a skew towards more modern handsets. And you can imagine that maybe the kind of people who want to collect their data and share it with other researchers and things like that are maybe going to be more on the end of buying a new phone frequently and that sort of behavior. Then at this point here, what happened was we did a collaborative study with a cell phone company. And what they wanted to do was collect the call data records from the network and handset measurements from the handsets for the same set of people, and then compare the views that you get from both sides. So they sent an SMS message to 10,000 subscribers, offering them 5 gig of free data for running Device Analyzer. And 2,000 of them participated and produced this skew here. And the country they targeted was Bangladesh. So this is the Bangladesh effect on biasing our data set. And you can see it had quite a significant effect on the versions of Android that were being run. Obviously, older phones or older versions of the OS were much more prevalent in that country. So if you're using the data set, you have to be a little bit careful about exactly what you're averaging over. Most of the stuff that I'll show you later, we've done a sort of a sensitivity analysis where we either keep the data in or we take it out, and it doesn't have a significant impact one way or the other, but you just have to, if you report average Android version, you're in trouble. So I said I'm going to talk about some of the uses of the data. I'm just going to go through, but if there's something that's interesting, please put your hand up and stop me, and I can go into more detail on anything. Or if you don't understand what I'm talking about, then I'm happy to discuss. So the API version tells you the library compliance that the Android handsets has, but you can go a level deeper and ask for the OS version, which tells you like the patch level of the particular update that the phone is running. And the graph obviously has the same shape. Now, Google doesn't publish the distribution of OS versions that they see on the Play Store, so now we're just into the Device Analyzer data. And you can see again the Bangladesh effect on the end here. So what we were interested in was, can we using the OS version number to track vulnerabilities to security problems in the Android ecosystem? So we built a repository of root exploits in Android. So things which you run the app, you're owned, you go to the website, you're owned, that kind of thing. And we wanted to see how long it takes for them to get fixed, and then for that fix to propagate through to all the Android devices that are being run in Device Analyzer. So this graph on the top shows you Android root exploits, and each one of them has a sort of a yellow box. The left-hand edge of the yellow box is the first disclosure of that vulnerability, so the first time that we could find that anyone admitted or notified that there was such a problem. And then the right-hand edge of the yellow box is the first time a patch appeared somewhere upstream. So it might be in the open source projects, in the Linux kernel, somewhere like that. So that box gives you sort of the minimum time to fix that any device could have. Now the bottom graph, which is at the same time scale, shows you the proportion of devices which were vulnerable to a root exploit. So you can see at this point here, the APK duplicate file exploit was discovered, and that was a platform vulnerability that affected all versions of Android. And so all devices in Device Analyzer were insecure at that point. And then slowly over time, manufacturers rolled out fixes to those phones. The yellow part on the graph is where we don't know. So they're devices where we haven't got enough information to know exactly what patch level of the OS they're running. So if you're feeling pessimistic, you can color the yellow in red, and if you're feeling optimistic, you can color it in green. And it's definitely the case that this bit should be red because there was no fix to the APK duplicate file until the end of this box, for example.
Oh, so why isn't it? Oh, I see. So you don't have the information, but you know that that is in fact red because there's no fix for it.
Yeah, so we get basically an update in the device analyzer stream when an OS update applies. And so if you don't have one for a while, then we don't know what version you're running. Obviously, this distance here is somewhat concerning. It's a good 6-month period. And this distance here is somewhat concerning in that there are a whole bunch of devices which are just never receiving updates in time to fix the device.
Bad year for Android, right? Because you have almost a year of unpatched vulnerabilities.
Yeah, I mean, these are not so terrifying as they seem because APK duplicate file, for example, was a exploit that had to be installed, had to be within the app that you downloaded. And so if you were using the Play Store, then Google was just rejecting those apps from the Play Store and getting rid of the vector. But some of the other ones are actually sort of exploits through the web stack or something, and so you go to a website and you get bitten. The reason, of course, this takes so long is that you've got the upstream open source projects which have to fix the bug, then Google has to pull it into Android, then it has to go to the handset manufacturers, then it has to go to the telcos, and then it has to get rolled out to the devices. And of course, most people sit there and their phone goes, I've got an update to install, do you want to reboot now? And everyone says no. So there's a long stack through there, which we don't have data for iOS, for example, but because the stack is much shorter, we expect that Apple can be much more effective about pushing a patch. So that said, does anyone want to have a punt on what the best device is worth or getting updates through? Google devices. So Google sponsor a handset, they pick one, it's the Nexus devices. And so this is the Google Nexus device, and you can see this is just the proportion of Nexus devices running different versions. So I guess interesting things on here are firstly that these lines are very vertical. So once they start pushing an update, it actually does get through the handsets quite fast. And it's not the case that lots of people are saying no, 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 no. They're actually, people are accepting the updates. There's also a huge number of OS versions which don't get widely deployed. So this, we suspect, is Google doing some sort of A/B testing. You know, you trial a new release as one on 10% of your users. You see whether it works or not. If it creates a new problem, you pull it, and if it seems like a good thing, then you upgrade it and send it to everybody. From the look of this, it looks like that they never succeed in that trial because the trial version never expands. But it could just be that they pull it and then make a new release to everybody with the new features in. So you can't really infer much about that one way or the other. But yes, in general, the Google devices are the best, and you would expect that that would be so because they have a smaller stack of intermediaries before it gets from Android to the handset itself. So I talked about the handset versus the network view, and this is AT&T is not the telco we worked with in Bangladesh. This is a different study. And what they did was they computed something they called daily range from locations that they estimated from call data records. So every time your phone interacts with the cell tower, text messages or phone calls, they get a record. And from that, they computed the circle which encompasses all of your movements for a day. And they called that your daily range. So what we did was we computed daily range from the coarse-grained location measurements that we get from the handset to see whether we see the same or different behavior. And we expect, well, because we're getting location measurements from the handset, we get more updates than you do for CDRs. And we also expect to have more precision because the Google location database takes into account access points and all of that sort of stuff, which AT&T can't use. But AT&T hit way more users than we could ever do with the device analyzer data. So AT&T, they were getting about 21 locations a day, but they hit 5% of AT&T subscribers, whereas we only had 208 locations a day and only 140 people in the two areas that AT&T looked at, which was New York City and Los Angeles. So just quickly what the numbers were, AT&T found a daily range of 7.2 miles in New York, and we found a daily range of about 7. LA, they found a range of 9.5 miles, and kind of intuitively, you would expect that people in LA are traveling a bit further than people in New York. Just thinking about the way the cities are designed, so that kind of makes sense. And we found 8, so we're in the right, we're close. At the weekends, we're off by about 50%. And maybe that suggests that people running Device Analyzer don't get out much at weekends. Again, it's just the small number of people there is meaning that we're not seeing the same sort of behavior that the AT&T people were.
Could it be some bias because you have like researchers? They might be having their phones in labs, etc.
Yes, so there might be bias due to the fact the phones are not moving at all. They might be tethered to a desk. These are, I wonder if we filtered those out. Yeah, we only filtered for New York and LA. So yeah, any researchers in New York and LA who've installed Device Analyzer on their developer handsets and left them on their desks at the weekends are not going to see much daily range. So if you look at the median range, yeah.
Did you know from some other, I know you said you didn't do demographic splits, but do you have some notion that there were a high representation of researchers or folks from the academic community in your samples? Or
we have an intuition that those are the kind of people who might want to do this. We also see some pretty strange devices in the data set. So there's one with hundreds of network interfaces, for example. So I would really hope that's a developer handset, but we don't have any concrete information about that. So the median range, the median daily range we found from the coarse grain measurements was 5.8 miles. But if you simulate the median range that we would have got if we'd only used CDRs, so just looking at locations that we got when there were text messages and calls, then our daily range goes down tremendously because we're just not seeing a huge amount of movement that these devices are doing because they're not interacting with the cell towers as they make the movement. And obviously AT&T is missing that too, but because they've got hundreds and thousands of people in there, maybe it's sort of averaging out in a different way. There, the 98th percentile of all daily ranges seen by AT&T was 4,000 kilometers, so this is like right at the extreme. Our 98th percentile is 10,000 kilometers because obviously with Device Analyzer, if you get on a plane and come off again at the other end, we know about it, but AT&T loses sight of you at the edge of their network. It's quite impressive that people managed to do 4,000 kilometers within an AT&T network, and so I'm not quite sure how that worked. Maybe a hop from one to the other and back again or something. So there's definitely questions about one or the other, and I think often, somebody asked me when I gave this talk the other day, where are my error bars on these numbers? And the answer is, well, there are so many errors that I can't even think about what these error bars might be. And the same is true of the AT&T numbers as well. They've got scale in a different direction. And comparing the two, where there's agreement, that's nice, but there are questions about both of these in terms of how you interpret them. One of the things we could do that, because we had worldwide data, is actually look at the daily range worldwide. And I put this in just because it kind of agrees again with what your intuitions might be. So people in India traveling sort of a daily range of about 1 mile, and then Europe in the middle about 4.5, and then the US about 9 or 10. Again, like your idea in your head about how far people are traveling every day, that kind of makes sense. And if you're in a tiny little island, then you're not going to travel very far. There's lots of white spaces because we filtered the data for only places where we had enough users to actually say something sensible.
Does each pixel correspond to a precise or correspond to that geographic location, or? It's
a spatial bin. So I can't remember exactly what the threshold were, but a certain number of devices had to be within that region, okay. And then the color gives you the average daily range within that region.
So where there's like a green square right next to a red square, like there was in India.
Yes, that just means that the people in that red square traveled way further than the people next to them, in a way that, yeah, I don't know. I guess you'd have to look at the map of India and try and work out whether that made sense or whether that was an artifact. Hmm. So another thing that you can do if you look at the handset and not at what the network operator sees is you can look at things like Wi-Fi, because the network operator doesn't have it. And if you are filling a building with Wi-Fi access points, then you'll normally plan your channel allocation so they don't overlap. And this means using generally the enterprise Wi-Fi channels. And so if you look at the distribution of Wi-Fi channels we see in Device Analyzer, you can see that the choice of these 3 channels massively dominates over anything else. So these are people probably at managed installations at work, and then this is probably people at home with a randomly chosen channel, whatever they chose to do. We were interested in this because Android phones at the moment seem to actively scan for wireless networks. So they just probe for all the networks that they know about. And there's been some privacy work where people have sat on the subway and just listened to the kind of networks that people are probing for. And then presumably if you hear a network ID that you don't like the sound of, you follow that guy down into a dark alley or something. The alternative to that is passive scanning, which is what phones used to do. But the problem with passive scanning is you have to go through all the channels, having a listen on every single channel, waiting to hear a broadcast. And so we were interested in whether if you were passive scanning, choosing your channel order more intelligently than just going through them in order could actually save you some power. And the answer is you can save a lot of power in the scan, but again, people aren't scanning enough to mean that it makes a big impact on the overall power budget of the phone. But it's definitely, you can do something. There are tons of papers where people have shown that people are really predictable and they only have a few places they go to, and we see the same thing. So this is just one user.
One of them was like work or school or your home.
Yeah,
that's not surprising, right?
So that's not surprising, and we see that too. The largest one I found was there's a user who has 105 fingerprints to summarize 95% of their locations. That's kind of a standard result that people have shown in other ways.
The FedEx.
Yeah, people who don't have an office and work on the road, or maybe I don't know. So just for fun, I was interested in how long a text message is, and the telcos don't seem to publish how long a text message is, but I found a very reputable source on Quora, which reckoned about 93 characters per message. We actually found rather smaller numbers, so our receive size was about 63 and our send size was about 45. Does anyone have an intuition about why the receive size is so much bigger than the send size?
Yeah.
Promotional messages.
Yeah, so robots. The 63 messages are like every Monday my bank texts me and tells me how overdrawn I am. And those messages tend to fill up the maximum size of a text message but not go over it. And so that increases the receive side. So one of the problems that we had with Device Analyzer was that we didn't have an explicit application in mind when we started collecting the data. We want to build a data set of what people do with their phones. And so that meant we didn't look in close detail at all of the stuff that we were collecting as we went. And one of the problems that we noticed now is that Android gives you a notification for every sent message. When you receive a message and it's too big to fit, you get notifications for each chunk. So because we only have the length of the message and we didn't record whether it was a chunk or not, you then have to try and guess whether you've received 3 text messages or one really long text message to try and work out the length. And so we sort of had a go at trying to work out whether or not something is a chunk or not. There are 3 different possible sizes depending on whether you're in a 7, 8, or 16-bit encoded text message. And the maximum size in 7-bit encoding is 160 characters, but you lose some if it's a chunk because you need some metadata in the header to tell you about it being a chunk. So we do our best bet to try and guess whether they're chunks and coalesce them, basically. From that, you can see the distributions of message sizes, and you can see just by eye that the received messages are much longer. And you can see sort of peaks here, which correspond to the bank sending me a message every Monday telling me how much money I've got. You can check hypotheses like this by looking at your own device. So once I thought about the fact that this might be that, I then looked at my own text messages and drew the distribution, and that's where they all are. Also, funny on this graph are these little white holes here, which are artifacts of the reconstruction algorithm, because we have a tendency to think that things of exactly the right size are a chunk rather than a message. Text messages with single character in are not very popular, but 2, 3, 4 characters are very popular. So that's probably smileys and lols and things like that. And then the message length dips a bit, and then people start using words again. So you get a funny thing at the beginning. But that's probably emoticon syndrome or something. So the final one I want to talk about is session duration. And this was done by a PhD student, Daniel Hintz, at a different university. And he submitted this paper to a workshop that we ran on Device Analyzer. So the reason we ran this workshop was that we were trying to encourage people to use the data set. And so we wrote a paper and we talked about the data set and we said, please contact us if you would like access to it. And we got exactly 0 people contact us and ask us if we could give access, which is probably a pretty sad statement about how many people read our paper. So what we did instead was we convinced the organizers of UbiComp in 2014 to let us have a workshop. And to go to the device analyzer workshop, you had to get the data and process the data and write a paper about what you did with the data, and then we would publish those papers in the workshop. And this drove almost immediately a huge uptake in people contacting us. One, because the UbiComp publicity engine is way, way bigger than my own personal publicity engine. And second, because you could get a paper out of it, and people like to get papers out of things. So that was kind of me. So if you ever have a data set that you need to share and no one's using it, then running a workshop is my #1 tip. It really worked well for us. It was great. So what Daniel did was he looked at sessions, and he was interested in particular in locked sessions. So now on a phone, you can use the camera and things without actually entering your PIN number. So he was interested in is anyone doing that? And how long do they last? And so he built this state machine to try and determine when a session began and ended. You don't need to see all the details here, apart from just the sheer sort of diversity about the events you get when you're trying to get something seemingly simple about is it a session or not. So if your screen is locked and you take a call, then you put the phone to your ear, and there's a sensor in the phone that says you can turn the screen off because it's on their head, and so you can save power. And so this causes the screen to go off, and you have to therefore absorb those events rather than think that something has happened to the session, because it's just a side effect of you moving the phone around. So these sorts of things really seem to catch us out quite a lot when we're trying to analyze the data. You draw a graph of it, it doesn't look like how you expect, and you then go in and find some more events and things like that. So just a word of warning, but this is quite a nice way, I think, of presenting what he did. So this was his result. So the bottom graph is unlocked sessions, and the top graph are locked sessions. And you can see that the median unlocked session length is about a minute, and there's a very heavy tail that carries on over here for unlocked sessions. And this is probably developer devices again. Like if you turn on Android developer settings, then one of the defaults is leave the screen unlocked if you put it on charge. And so there are probably people put their phone in and you get 8 hours. The locked session has these interesting peaks in it, and some of the locked sessions are pretty long, which maybe is some indication of that Daniel was looking for of people using these kind of features. But really, there's not much going on. Does anyone have a hypothesis about what the peaks are from?
Screen going off.
Yeah, so these are different manufacturer defaults of screen timeouts. So you can see that if you look at individual users, you get these sort of the session durations tap up at particular levels, because that's when the screen would like to shut off. The other thing that Daniel did in his paper, which was really neat, and we gave him a prize for best paper, was he compared his results with everybody else's who'd also collected data about phones and looked at how they used, and found general consistency with the session times and the number of interactions he was getting versus what other people had reported. One of the things that we think would be interesting with Device Analyzer is for those companies who have commercial data sets that they can't share with anyone to still use our data and do a cross-validation across the two, maybe answer a bit better the demographic question. And if they can't share their own data, they can at least share some sort of normalization information about what Device Analyzer would look like if it was collected in a different way or in a different study. So I think this kind of thing is really quite useful. And then maybe the most exciting thing is a non-academic output tool, which is in the UK in London. We have the Science Museum, and they have a new Information Age exhibit, which shows, among other things, the history of cell phones. And there's an interactive space with videos playing, and the statistics in that space come from the Device Analyzer data. And so here's me with the plaque. Really proud of myself. It was quite interesting working with the designers, because the way they designed this exhibit is they had a story writer who was writing scenarios about people using their phones. So Andy is in the States, he's trying to find where to go, he gets lost, he tries to phone for help, but he has no phone reception, but his GPS works, and then he's navigating and he runs out of batteries, and then fill all of those things in with statistics. And the problem was that because they were sort of creative people, they were quite happy to write any story we wanted. And the problem with the device analyzer data is you can tell any story you want because there's so much variation in what people do. And so we had lots of back and forth with me producing numbers and then them sort of going very politely that we don't want that one. Can I get a different one? And then they producing stories and me saying, well, I don't really have any numbers that match that up, and so on and so forth. So there's quite a lot of iteration, but actually you get quite a cool output. I'm told this is a permanent exhibit, so it's going to be there for the next 10 years. So there's plenty of time to get to London and see it. We've struggled quite a lot with sharing the data itself. That 1 terabyte is not really a big data set in the terms, but actually people have really struggled to download it or to store it. People email me with bug reports about the download client, and it turns out they don't have enough RAM. Or a really common one, people have enough RAM, but they use 32-bit Java virtual machines, and so they can't address their RAM. And then I look really clever when I say, oh, you need to run a 64-bit JVM, because it's just a standard mistake people make. Remote processing is another option that we haven't really looked into. There's been tons of work about how you can safely run other people's code on your data, and maybe we should be looking at that. The Science Museum people were really interested in how long does someone spend playing games versus how long do they spend doing email. And for that, you need to categorize applications. And that's difficult because the handset doesn't know the category of the application. That's only on the marketplace. And so you have to scrape data from the marketplace to work out what the categories are for the applications. And then better country coding would maybe help people do some more stratified sampling of the data set rather than being skewed to one part of the world. And yeah, as you saw at the beginning, the app looks like somebody drew it on a piece of paper, and we'd probably get some more users if it looked cooler. So there's definitely a new release needed. So I'll stop there and encourage you, if you have an Android phone, to install Device Analyzer. You can get your own data back directly. You don't have to go through us, but if you want the whole data set, there's more information online. And I didn't do all this work. It was done by a load of other people as well, and thanks to them. Thank you very much.
Question?
Yeah.
You mentioned country coding. Right now, if you don't opt in, how much country coding is there?
So for people who haven't shared their location outside of Cambridge, what you get are one-way hashes of lat longs, basically. And so you can sort of know when someone goes back to the same place, but you don't know where in the world they are at all. And so doing that kind of sampling is really difficult. And so what we want to do is just turn those lat longs into countries and take the data set with those so that people then can do some sampling. But at the moment, that's not in there. Categories for applications are. Yeah.
Did you do any survey of some of the, excuse me, commercial products that pick up analytics from phones? There's a company, Yahoo acquired Flurry. There are a bunch of those that just pick up all kinds of. Was that to the best of your knowledge, a subset of the sort of things they do, or is it that?
We haven't done an explicit survey of what's out there, and part of the reason for that is we built this 5 years ago, and keep running around checking is just not something that we've done. We probably should. As far as I know, we are collecting a superset of what most other things are collecting. I think partly because if you're doing this on a commercial basis, you have to be extremely careful about how you communicate what you're doing. And I think we've been cut quite a lot of slack because we're a university. Maybe there's a comment there about what kind of research universities should be doing. And the kind of stuff that corporates would find really hard to do is exactly this kind of thing, because everybody thinks they're evil. So we are probably, even though we've tried very hard to be non-invasive and communicate what we're doing, we're probably collecting more detailed data than quite a few other studies have done. For the purposes of saving power consumption, we don't poll that information very frequently, and so lots of people moan at us about the lack of fidelity in the data. Someone wants to do activity recognition, they need the accelerometer readings. If we collected those at the kind of rate that they need, no one would run Device Analyzer for in 10 minutes because their phone would run out of batteries. So there's problems there, and so some custom data sets would do better in that sense. Yeah.
Do you have a quantified impact on the power consumption? I came right at the end of the thing.
Back of the envelope, we think about 3% from our own experience.
Like drain tests where you see it drains and then at like 10 hours without your thing.
We haven't done that, and part of the reason is that it depends on how you're using your phone, because lots of our consumption is driven by events being raised on the handset.
I see.
So we're probably just amplifying what you're currently doing rather than having a constant. One of the things that we do is we try and defer a lot of our processing till times when the phone is on charge or is charged. And you can see this clearly in the data. You know, phones are low power devices for some of the time, and then the rest of the time they're amazingly powerful things because they've got a charger plugged into them. And so we stream all the samples to SD card, and then we gzip them when we have battery and things like that to try and save it. But again, we haven't quantified that. Interestingly, one of the mistakes we made at the beginning was that we stored all of our data in the Android SQLite database that goes with each app. And if you do that, then when someone looks at the size of the app, it tells them how big the app is, and you're at the top of the list, so you get uninstalled because you're using all the space on the phone. So what we do instead is store the data on the SD card, and then you're not in that statistic. And so then you're not at the top of the list, and so then people don't uninstall you. So that small change saved us a huge amount of uninstalls. People just going, yeah, you're the one using all the space on my phone.
Is that a meaningful change? That is to say that are there different limits for the internal storage on the phone versus storage on an SD card?
Yes.
So it is meaningful. You're not just tricking people and deceiving them.
No.
Right.
You're actually
shifting the data to a less critical resource.
So as far as I know, if you're using a stock Android OS, you can only install apps onto the internal flash of the phone. You can't install them onto the SD card, and so that space is by definition more precious.
Yeah.
Newer phones seem to have built-in SD cards, and that seems to be blurring the line a bit more. But yeah, it's not a complete con job. The other thing is, obviously, if you store data in SQLite, it's a database and it's trying to do relational stuff. And what we needed was an append-only log, and so it took more space anyway because it was the wrong storage mechanism for what we needed.
Any lessons to share as far as the methodology statistics that you followed as far as what data to keep, what data to toss away? Was it with respect to the dimensionality of the data, if there wasn't enough rows, or was it more towards balanced designs where you wanted to have equal sample sizes with different byte bins?
Good question. So because we didn't have all the applications in mind when we collected it, we just took kind of what was there and guessed, and there are various points where that's not been the right choice. So which applications are running? Loads of people are interested in that, and with hindsight it's kind of obvious that they would be. And because we're only polling every 5 minutes, we have big uncertainty. I mean, there are lots of apps that people don't even run for a minute, let alone 5. And so we should have tried harder to capture those events. The other one is lots of people are interested in activity recognition and what people are actually doing with their phone. And we could have run classifiers on the device. So we could have streamed accelerometer readings to the SD card, run classifiers on them at night in the same time we were doing our gzips. And that would have given people more information, like the classifier said the phone's at rest at this point, or the classifier said that the person was walking at this point. And there are a whole load of studies that we couldn't help with because of that too. So I guess the overall lesson is maybe the classic research adage of like have a hypothesis before you do your experiment. And for us, that should have been thinking of all the things that people would want to use this data for and getting it right. And in actual fact, what we did instead was collected all the stuff that we could get our hands on and hope that it would do. And so there's been some cracks there because of that. But the people are still managing to do stuff with it, but it's easy to see ways that you could have done better.
And in the dimension of observations, I meant not so much in the dimension of the variables you were collecting, the columns. I thought at some point you mentioned during the location studies, the range of people, that you threw away some places because you didn't have enough data to be meaningful.
Yeah.
Whatever that meant. I was curious what that meant.
We generally say if we don't have a month or 2 months worth of data, we're not interested in your readings. So we throw away very, very short-term contributions, or like with the vulnerabilities one, try to show that we don't know in that space. it would be, that's kind of a stab at doing some of this normalization across the data set, but we don't have enough demographics to do a better job. One of the debatable questions is, should we have asked for demographics? So when you installed the app, should we have asked you questions? And what would that have done to the non-participation rate if we had done that? Or maybe should we have offered incentives for people to give us demographic information over and above what was on their phone? And that's starting to become more of a social science study than a measurement study. But again, those questions would be interesting to know the answer to.
So do you have any data connectivity patterns in terms of how many different access points am I connecting to every day, etc.?
Yes. So all of that, the MAC addresses of the access points are all hashed, but it's a stable hash for the device. So you know if I'm going back to the same one. So we can show how many different access points you see. We can see what channels they're on, what kind of authentication they're using. We can see hashes of cell location. So again, like how you move around and that sort of
So
stuff.
this is only in terms of discovery or connectivity?
We have discovery. So every time there's a scan, we trigger a scan every 5 minutes. Then we collect everything that the phone sees.
A connection whether I'm actually using an access point or just discovery?
Yes. So what you're connected to, and also the scan about what's around you. Yeah.
If you were directly talking to Google right now, what would you say? Like, what information do you need from Android that it's like the key thing that you've been trying to get, and it's been a pain in the ass to get, that would just make it so easy if they just gave it?
Which apps? Events when apps start and stop.
Oh, you can't use the kernel tracing?
So we could have tried harder with the kernel tracing, and I think there's a hack you can do if you look at the logcat output, because it gets logged. But we really struggled anyway with compatibility between Android handsets, and so a supported API for starts and stops would be really nice.
To be fair, so this is Google.
Yeah. Yeah.
Compatibility between handsets is a humongous.
I'll just give me 1 minute. I'll show you a compatibility problem. So time is a big issue. We tried logging the wall clock time of events, and it seems that when you install an Android OS update, it resets the clock back to 1980 for a bit, and then it comes back again when it gets an RTC update. So instead what we did was we measured uptime milliseconds from the system clock, expecting that this would go up monotonically, and it doesn't. And sometimes it jumps and then goes back to where it was, and sometimes it jumps and stays there, and sometimes it goes backwards. And there's a whole lot of sort of different behaviors that these phones are doing that we really can't explain. And so we do a whole lot of work trying to back infer a reliable measure of time from all of these different pieces of information. But basically what's in the device analyzer log is every event is timestamped with the system uptime. And then we log real-time clock events when we get them. So if there's a network time correction or a GPS time correction or a user's made time correction, they just go in the log. And then we try and do a sort of a linear regression to try and fit the updates onto the real time and then stretch them out as they need to go. But again, as like different devices behaving in different ways has been one of the sort of overriding themes about this work.
Are you saying that the system uptime decreases or regresses even if you don't reboot the phone?
On some devices.
That sounds like an error.
Yeah.
Oh, yeah.
I mean, it sounds like a kernel error, really, actually. Either that or somebody's really doing something they shouldn't do.
So there are research devices in the data set, like this one with hundreds of interfaces.
Okay.
So it's possible that it is someone doing something funny, but it does happen on a reasonable number of devices, but it doesn't happen very often on those devices, and it's not correlated with manufacturer. So it's not all of this manufacturer's phones that do it. We just see it occasionally, and it totally causes a problem with the time recovery stuff.
Because normally, if you look at Linux kernel, you only increment the system uptime. You never subtract from it, unless I guess it can overflow, but that's rare. Yeah, that's really strange.
No, it was a bit. We were surprised by that. We thought we'd done the most robust thing possible, and it wasn't. Okay. Great. Well, thanks very much for coming. And if you have any questions, by all means, send me an email.
Thank you, Andy.
Your